Okay, here's the problem solving video for problem 3.89. It says find V0 using mesh analysis, and you'll notice this time we have a dependent current source, and you'll see where the dependent variable is. It's the current flowing in this 6K resistor in that direction. So we'll start off from our problem solving strategy on page 117. Let's assign mesh currents. Okay, so there are our assigned mesh currents. So now we have three unknowns, I1, I2, and I3. We're going to need three equations, and since we have a dependent current source, we're going to have a constraint equation. Okay, so let's handle our constraint equation, and we're going to write that constraint equation and treat that dependent current source as if it were a constant, and then we're going to substitute in for Ix. So if we look at our constraint equation, we want the current down, and we know that current would be I1 minus I2 is equal to 0.5 Ix. Okay, so now let's look at our diagram circuit, and we can see where the current Ix is, and if you'll notice from the diagram, that's the negative of I3. So this is 0.5 times negative I3. So then our constraint equation becomes I1 minus I2 plus 0.5 I3 equal to 0. Okay, so there's the first equation. Now, we decided we needed three equations. We've got one. We need to get two more. What we can do is we can apply KVL to mesh 3 that doesn't have any current sources. Then we're going to have to use a super mesh to get the third equation because of the presence of the current source. So for mesh 3, let's write the KVL equation. So if we start here and go around, we'll have 6K times I3 as a drop across this resistor. This is minus 8. Then we'll have a drop here that's 3K times I3 minus I1. Then the drop here will be 6K times I3 minus I2 equals 0. Okay. That no current sources involved in that mesh. We can go and apply KVL to it. The equation then, when we simplify it, minus 3K I1 minus 6K I2 plus 15K I3 equal to 8. Okay, so there's our second equation. Now again, remember, we need three equations. Our first equation came from the constraint equation. Our second equation came from mesh 3, and then we're going to use a super mesh to get our last equation. And really you can think about replacing that with an open and looking for a loop in the circuit. So there are actually two possibilities. One would be this one. Okay, and then the other one would be the outside. So let's apply KVL to the outside to get our third equation. Okay, so this is making use of the super mesh. So if we start here and go around, we'll have 2K times I1, so drop there, plus 3K times I1, and then we'll have 4K times I2. That's a drop here. We'll have minus 12. Here we'll have 6K I3. Then as we come around, we'll have a minus 10, and that'll be equal to 0. Okay, now let's rearrange that one a little bit, and when we do, This equation becomes 5Ki1 plus 4Ki2 plus 6Ki3 is equal to 22. So there's our third equation. So the first equation came from the constraint equation. The second equation came from KVL for a mesh that didn't have a current source. And then to get our final equation, we used the super mesh equation. And in this case, we decided to apply KVL around the outside loop. Now, we're ready to solve. So let's write our equations in matrix form, and then we'll solve them using MATLAB. Okay, so here's our matrix. And there it is. Now using MATLAB, we get I1 is equal to 1.11 milliamps. I2 is 1.861 milliamps. And then I3 is 1.5 milliamps. And then V0 is 6K times I3. 6K times 1.5 milli is equal to 9. And there's our answer.